So now that you've reviewed limits on Khan Academy, we're going to start filling out the notes on page 168 in your note guide 11.1. A limit is how the output of a function, and again, output is f of x or your y values of a function, behave as the input or your x values approach some value. The notation of it is the limit as x approaches c of f of x is how you read that. In this example, we're going to use the table to find the limit as x approaches 0 of the sine x over x. So in order to do that, if you wanted to graph that on your graphing calculator, then all you would need to do is go to y equals, put in sine x divided by x, go to window, make sure that you're in radian mode, and then go to window, and you can change your window to negative 2 pi to 2 pi, count by pi over 2, and your y values negative 2 to 2. Then if you hit second table set, you're going to change under independent, you're going to change the auto to ask, and then go to second table, and now you can type in these values on your table. So what we're looking at here is we're looking at what is happening to the values as I approach 0. So first off, we're going to start from the right-hand side of 0. And when I plug in 1, f of x is 0.84147. So when x, and again I'm moving to the left towards 0, when I plug in a half, f of x is equal to 0.95885. When I move even further left towards 0, 0.1, I get 0.99833. And what happens when I put in 0.01? I get 0.9998. So you can see how close, the closer x approaches 0, the closer y is approaching the number 1. Now, if we were to do the same thing from the left-hand side of 0, you could start with negative 1, and you get 0.99833. If I move now to the right towards 0, 0.01, you can see 0.9998. And so even though if I were to plug in 0, f of 0 is going to be undefined because you would have 0 at the bottom of that fraction. But the limit does exist, and the limit is what the graph is approaching from the left side and the right side, which happens to be 1. So the limit as x approaches 0 of the sine x over x is equal to 1. If you go ahead and hit graph, and you graph that function, you're going to see something that looks like this. Now when it hits 0, there would be an open circle, and then something like this on the other side. And it's not super symmetric, but I think you get my idea. As I'm moving in from the left towards 0, as x is moving in towards 0, the y values, or f of x values, are moving closer and closer to 1. And as I'm moving in from the right side, as x is moving towards 0, the y values are moving closer and closer and closer to 1. In example 2, we're looking at the limit from a graphical approach. So the limit as x approaches 2 of x squared subtract 4 over x squared subtract 2. So the first thing you're going to do is go to your graphing calculator, go to y equals, and graph x squared subtract 4 divided by x subtract 2. And instead of hitting graph, hit trace. And you are going to trace along the function. And what I want you to see is as we are approaching x equals 2. So here is x equals 2. As I am approaching from the left-hand side. I'm here, and then at 0, I'm here. And you can see as I am moving towards x equals 2, what is f of x getting closer and closer and closer to? So you can see when I hit 2, I'm undefined. So f of 2 actually is undefined, but the limit exists because the limit is what are we approaching. And so if you follow this across, it looks like we are approaching 4. And you can also see that from the other side. So from this side, here is x equals 2. And if we follow this function, so when x is here, when x is here, f of x is up here. When x is here, f of x is up here. And as I am moving in towards, so I'm moving in towards x equals 2, what is f of x approaching? And if you look here, even though we're undefined here, f of x is approaching 4. So the limit as x approaches 2 of x squared subtract 4 over x minus 2 is equal to 4. One thing that's important to note is the limit only exists if from the left side or the lower bound side and from the right side or the upper bound side we are approaching the same value. So you see that we're approaching 4 from the right and we're approaching 4 from the left. And so therefore the limit exists and the limit is 4. Example 3 is finding the limit by direct substitution. So far we have found the limit by using a table, the limit by looking at the graph, and now we're looking at the limit by directly substituting in the value. Now this process is the easiest if you can get it to work. So looking at this, it says the limit as x approaches 2 of this function. So all we're going to do is we're going to plug in the value of 2. So the limit as x approaches 2 is equal to 2 squared subtract 2 times 2 plus 8 over 2 plus 2. So if we go ahead and simplify that, we get the limit as x approaches 2 is equal to 4 subtract 4 plus 8 over 4. And this is going to equal 2. So the limit, we could say the limit as x approaches 2 of f of x is equal to 2. And f of x is referring to this function right here, x squared minus 2x plus 8 over x plus 2. In this example, the limit as x approaches -3, we can't direct substitute to start with because -3 plus 3 would give us 0 in the denominator. So before we use direct substitution, we are going to want to factor the numerator. So that's a difference of 2 squares, 3 plus x and 3 subtract x. And the denominator is x plus 3. And again, this is the limit as x approaches -3. So you can see that the 3 plus x and the x plus 3 are going to cancel. So now we've got the limit as x approaches -3 of 3 subtract x. So we can go ahead and directly substitute at this point. This is going to give us 3 subtract -3, which will equal 6. So the limit of this function is 6. Just a reminder before we do example 4 is a difference of cubes is equal to a subtract b times a squared plus a times b plus b squared. We remembered how to factor a difference of cubes using SOAP. S, the first sign is the same as the original. O, the second sign is the opposite. And the last sign is always positive. So now let's look at example 4. The limit as x approaches negative 3 of x cubed subtract 1 over x plus 3. We cannot use direct substitution. If I put negative 3 in for x, I get negative 3 plus 3, which is 0 at the bottom of a fraction. So the next thing I'm going to do is factor and see if anything cancels. So when I factor the numerator, which is the difference of cubes, I get x minus 1 times x squared plus x plus 1 over x plus 3. You can see that nothing in the numerator is going to cancel with the denominator. Because of that, there's nothing else I can do, and so the limit is equal to d n e. And d n e stands for does not exist. Example 5 is what we refer to as a one-sided limit. The limit as x approaches 2 from the right. See that little plus? That means from the right-hand side. So we're going to find the limit as x approaches 2 from the right of f of x. F of x this time is a piecewise function. And I graphed the piecewise function so you could get a visual of what's happening. So down here, reminder of how to graph a piecewise function. The red is the x squared. And so if you put in 0 squared is 0, 1 squared is 1, 2 squared is 4, and then do you notice x is less than or equal to 2? So this is a closed-in point, and I only want everything smaller than 2. So that's this part of the graph here. The other piece is this green line, which is a line, 3x subtract 1. So I started at negative 1 for the y-intercept, and I did rise 1, 2, 3 over run, which is here. Now that is not in my domain because my domain is greater than 2. So I did rise over run again, rise 1, 2, 3, and run 1. Notice it's not including 2, so I did an open circle, and I drew this piece of the graph. Now the question is asking us when, where, or what is the limit as x approaches 2 from the right. So this is the right-hand side of the graph. And what you're going to be doing is we are going to approach 2. So here is 2, and we're going to be on the right-hand side. So when I'm here, I'm up here on my function at, let's see, 2, 3, 4, 5. At 5, I'm up here on my function. At 4, I'm up here on my function. So I'm trying to see where I'm approaching. At 3, I'm here. And you can see I'm coming in to the number 2 from the right-hand side. So at 2, I'm here. Now I know it's undefined, but I'm not finding f of 2. I'm finding where the function is approaching. And it's approaching when x is 2, f of x is approaching 5. So therefore, the limit as x approaches 2 from the right-hand side of the function f of x, which is this piecewise function, is equal to 5. Now there's one other way that I can do this, and that's by using substitution. So if you want to use substitution, what you'll do is you have to pick the piece that is on the right side of 2, or upper bound. So we are going to have to use the linear function if I'm going to use substitution. So what I would do is the limit as x approaches 2 from the right of f of x is going to be 3, and in place of x, I'm going to put 2, subtract 1, and 6 subtract 1 equals 5. So the important thing is that you use the correct piece to plug in if you're going to use direct substitution in order to solve this problem. I do want to point out, if the problem was asking you for the limit as x approaches 2, and I didn't specify the right-hand side, then f of x, the limit as x approaches 2 of f of x is going to equal, do you know? Does not exist. Because from the left side, the limit would be 4, and from the right side, the limit is 5. And you have to approach the same value from the left and the right side in order for the limit to exist. In example 6, the limit as x approaches 2 from the left-hand side. How do I know it's the left-hand side? It's this little minus right there. So how do I find the limit as x approaches 2 from the left of the square root of x minus 2? Let me just remind you of what the graph looks like. So here's the graph. We know that y equals the square root of x, got shifted opposite of what you think to the right 2. So I shifted the graph to the right 2. Here's the graph. Now the problem we have with this graph is there's no function over here. So I cannot approach 2 from the left-hand side because there's no function for me to approach. Therefore, the limit as x approaches 2 from the left-hand side is going to equal does not exist. Here's a reminder one more time, the difference between a one-sided limit, which is from the left or the right side, versus a two-sided limit. So if it has the limit as x approaches c of f of x, then we know that the limit from the left side and the right side have to be the same in order for the limit to exist. Now let's answer the following questions about example 7 to see if you understand the limits. We have a piecewise function that jumps. So the function is here, and then the function jumps up here, and it's actually equal here, and then you've got this piece. So looking at this piecewise function, let's review the limits. A, the limit as x approaches 1 from the left. Again, that little negative right here means from the left. So what we're doing is we're coming in from the left-hand side. And as x is approaching 1 from the left-hand side, it looks like f of x is approaching, what's the y value? Is -1. Again, we don't care what it actually equals, we just care what it's approaching. That's what the limit is. Let's look at B. The limit as x approaches 1 from the right. See the little plus means from the right-hand side. So now x is approaching 1 from the right side or the upper bound side. So as x is getting closer and closer and closer and closer to 1, f of x is approaching, that's right, 2. All right, the limit as x approaches 1. Now, this does not have a plus or a minus, so that means we are approaching from both the left side and the right side. Since those numbers are different, from the left side, as x is getting closer and closer to 1, f of x is getting closer and closer to -1. From the right side, as x is getting closer and closer to 1, f of x is staying at 2. Therefore, the limit does not exist. Did you guess it right? I hope so. All right, last one. F of 1. This means we are going to evaluate the graph. We're not finding the limit. We're just figuring out what is f of 1. So when x is 1, we come over to 1, then f of x is equal to that point right there, which is at 1. In this example, we're going to find the limit as x approaches 0 of tan x over x. So the first thing we're going to use is our identity over here, that tangent x is equal to sine x over cosine x. So this is going to be the limit as x approaches 0 of sine x over cosine x divided by x. So I can rewrite this as the limit as x approaches 0 of sine x over cosine x multiplied by 1 over x. I did keep it, flip it, and then change the divide to multiply. From there, I can rearrange this problem. And using my properties, I can write it as the limit as x approaches 0 of sine x over x times the limit as x approaches 0 of cosine x. And you can see I just rearranged this because it's all multiplication. So I can write sine x over x, and then that would leave me with 1 over cosine x. I wrote that wrong. There we go. 1 over cosine x. Now let's find the limit. The limit as x approaches 0 of sine x over x is going to be equal to 1. And that was our first example in this section. And now we're going to need to find the limit as x approaches 0 of 1 over cosine x. So let's go ahead and use direct substitution on this part of the problem. So this is going to give me 1 over the cosine of 0. And the cosine of 0 is 1. So that's 1 over 1, which equals 1. So when I multiply those two limits together, I get 1 times 1, and 1 times 1 is equal to 1. So what is the limit as x approaches 0 of tan x over x? It is equal to 1. The you-try example you should try on your own and then check it with the video. So on this problem, if you take 2 and you directly substitute it in here, 2 squared is 4, and 4 subtract 4 is going to give you 0 on the bottom. So you can't start with direct substitution. Instead, what we're going to have to do is take the limit as t approaches 2, and we're going to have to factor that function. And so this is going to give me t times t is t squared, and we've got 2 times 1 is 2, and these are both going to be negative. On the bottom is a difference of squares, so we have t plus 2 and t subtract 2. You can see that the t subtract 2's are going to cancel. So now we can use direct substitution. So I'm going to go ahead and substitute in 2 for t. So I'll do that in red. So we've got 2, and then you've got subtract 1 over, and then we have 2 plus 2. 2 subtract 1 is 1, and 2 plus 2 is 4. So therefore, the limit as t approaches 2 of this function, and you can just call that function t of x if you would like, is equal to 1/4. And the reflection, explain how left and right hand limits relate to two-sided limits. The answer to that question would be, in order to have a two-sided limit, the left and the right hand limits have to be the same. So the left and the right have to be the same in order to have a two-sided limit. Okay, good job. Now you're going to go ahead and work on the assignments that go with lesson 11.1. You can do it. Keep up the good work. This is going to really help you with calculus next year.